Good day, ladies. Today we are going to look at intermolecular forces. I know the first part of this we have already done, but I'm just going to go through it quickly again just to revise. So, if we look at the water molecule over here, everybody should be able to tell me that between oxygen and hydrogen, one electron pair is shared, and that is why I refer to this as a covalent bond. You should also be able to tell me that because of the difference in electronegativity, oxygen's being 2,5 and hydrogen 2,1, that the oxygen end ends up being slightly or partially negative and the hydrogen slightly or partially positive, and that is the reason why this bond can be described as a polar covalent bond. Also, you should be able to tell me that because of the shape of the molecule and this difference in electronegativity, this molecule can be described as a polar molecule. But to get back to the polar covalent bond, this bond can be described as an intramolecular force because it's all about the forces in the molecule. This is also sometimes referred to as interatomic forces. In other words, forces between the atoms in the molecule, and this is what we concentrated on in the previous section. We looked at what happens between atoms in the molecule. Now, this new section is about intermolecular forces. So what are we looking at now? We are looking at the forces, as you can see over here, between molecules. Now, before we look at that in a little bit more detail, let's just take a look at this very quickly. So, a polar molecule like a water molecule, what does that mean? The oxygen end is slightly negative, the hydrogen end slightly positive. This polar molecule can be described as a dipole. I've got two poles that form, and this is a permanent situation. Now, the following can happen in a non-polar molecule. As you can see, I've got a hydrogen molecule here as an example, and a hydrogen molecule or a non-polar molecule can form an induced dipole. So a dipole is brought about in the molecule. And what happens is this. So when we described this as a non-polar bond, we said that the electron pair is shared equally between the two hydrogen atoms. And that is why it's a nonpolar bond, and it's also a nonpolar molecule. But what actually happens is electrons are not stuck in one position. They move in energy levels around the nucleus of the atom. So at some stage, the electrons could be more to the one side of the molecule, which makes this side of the molecule slightly negative, and the other side will end up being slightly positive. So it is a dipole but it is a temporary dipole, because the next second the electrons could be over there, and then this side is slightly negative and that side is slightly positive. So polar molecules form dipoles. That's a permanent situation. Non-polar molecules can form induced dipoles, and that is a temporary situation. So now that we've got that out of the way, let's see what you need to know about intermolecular forces. There are different types. The first one that we are going to look at are ion dipole forces. I know technically it says intermolecular, between molecules, but it's also the term that we use for between particles, in this case between ions and molecules. So, ion dipole forces are the forces that we find between ions and polar molecules. The best example would be, this is what happens if I take sodium chloride, table salt, and I dissolve it in water. Sodium chloride is an ionic substance. It forms between sodium, which is a metal, and chlorine, which is a non-metal, and there is a transfer of electrons that takes place. The sodium loses its electron and becomes a positively charged ion. the chlorine gains one electron and becomes a negatively charged chloride ion. All these ions pack together in this structure over here, which we refer to as a crystal lattice. So, what happens when I add the salt to water? The salt crystal is surrounded by water molecules. This water molecule, as you can see, the oxygen side, which is slightly negative, will point towards the crystal, and because of this attraction between positive and negative, this positive ion can actually be pulled out of the crystal lattice. On this side, we can see that the positive hydrogen end of this molecule points towards the crystal. So because of the force of attraction between positive and negative, the negative ion can actually be pulled out of the crystal. And this is then exactly what happens when the salt dissolves. We also say that the salt dissociates over there. So eventually, what will I have? If I've got a beaker filled with salt water, I've got positive sodium ions surrounded by water molecules. I've got negative chloride ions also surrounded by water molecules. But take a look here. The oxygen end of the water molecule points towards the positive sodium ion, and the positive hydrogen ends of the water molecule point towards the negative chloride ion. And this attraction between the molecule and the ion, and here as well, the molecule and the ion, that is referred to as ion dipole forces. Right, then the next type, as you can see, we've got ion-induced dipole forces. So what have we got here? We've got the forces between ions and non-polar molecules. So here, I've got a positively charged ion, I've got a non-polar molecule, but the positively charged ion can attract the electrons and they move to the one side. And what is going to happen? An induced dipole will form here. And for a short period of time, this side of the molecule will be slightly negative and that side slightly positive. And this attraction between the ion and the induced dipole is referred to as ion-induced dipole forces. Okay. Then our next lot, these are referred to as van der Waals forces, and there are different types of van der Waals forces. The first type is referred to as dipole forces. So now we know these are the forces between polar molecules. An example of that would be, here I've got a HCl molecule, there I've got a HCl molecule. We all know this is going to be a polar molecule because hydrogen electronegativity 2,1, chlorine 3. The bond that forms is going to be a polar bond. The molecule is going to be a polar molecule with a slightly negative and a slightly positive side. And this attraction between the two molecules, this slightly positive side and that slightly negative side, is referred to as dipole forces. Then we've also got a special type of dipole force, which is referred to as hydrogen bonding forces. I know some people just refer to it as hydrogen bonding, but I sometimes think people then might get it confused with covalent and ionic, and that's bonding, but these are intermolecular forces. So I prefer to use the term hydrogen bonding forces. So these are the strongest van der Waals forces. These are the forces that we find between molecules, because remember it's intermolecular, between molecules, in which hydrogen is covalently bonded either to nitrogen, oxygen, or fluorine. So hydrogen bonding forces we will find between ammonia molecules. So that is hydrogen bonding forces between those molecules. It will also be found between water molecules, so hydrogen bonding forces. and it will also be found between hydrogen fluoride molecules. So those are your only examples of hydrogen bonding forces that you need to know about. And then you might ask yourself the question, why are these special? Why do we find this special type of dipole-dipole force? Because that's a non-polar molecule, that's a non-polar molecule, that as well. Why not just normal dipole-dipole forces? And here is the reason over here. What's special about these molecules, we've got the hydrogen atom, which has a very strong positive charge. It's bonded to another atom that is relatively small, and there's a large difference in electronegativity between the hydrogen and the other atom, the nitrogen or the oxygen or the fluorine, which results in very strong dipoles that form. And that is why this hydrogen bonding forces, this is an example of the strongest type of van der Waals forces that we can get. Right, then our second type of van der Waals force, we've got dipole, induced dipole forces. So this is what we'll find between polar molecules and non-polar molecules. So you can take a look over here. I've got a water molecule, which is a polar molecule. I've got a hydrogen molecule, which is a non-polar molecule. But what could form there is an induced dipole, because this negative side could repel the electrons so that they move to the one side. So this side becomes partially positive and this partially negative. And this attraction between this negative side and this positive side, between a polar molecule and a non-polar molecule, we can describe that as dipole, induced dipole forces. And also just remember, a dipole is a permanent dipole. Induced dipole is a temporary situation. And then the last type that you need to know about, induced dipole forces. And this is what we will find between non-polar molecules. Induced dipole forces are also referred to as London forces. And these are the weakest intermolecular forces that you can find. Take a look over here. I've got a hydrogen molecule and a hydrogen molecule. So non-polar, non-polar. When all the electrons are on the one side, the side is slightly negative, that side is slightly positive, so it's an induced dipole. And this slightly negative side could cause the electrons in the adjacent molecule to move to this side over there. So what happens, this side is now slightly positive, that side is slightly negative. And this attraction between non-polar molecule and non-polar molecule is referred to as induced dipole, or London forces. And that is it, ladies. That is what you need to know about intermolecular forces. So over here, these are the 4 exercises that you've got in your textbook. So this is what you can work on for the next 2 days, I think maybe. And then what I will do on Monday, I will post the answers to those questions in these exercises for you so that you can mark your work. Thank you.